In the early morning hours of a crisp June day in 1982, deep inside the permafrost wilderness of western Siberia, the earth tore open, a colossal fireball, burning with the blinding fury of 3 kilotons of high explosives, erupted thousands of feet into the subarctic stratosphere. Thousands of miles away, alarms began wailing inside the subterranean bunkers of the North American Aerospace Defense Command. U.S. early warning defense satellites had picked up a massive, unexpected nuclear-scale explosion in the remote interior of the Soviet Union. Analysts scrutinizing the data discovered no radioactive fallout in the upper atmosphere, and no missile launch plumes were tracked by early warning radar. In Moscow, officials inside the fortified walls of the KGB were thrown into total confusion. An emergency commission of engineers and metallurgists dispatched to the smoking Arctic crater concluded that brand new automated control valves had suffered a catastrophic mechanical failure. What the Soviet leadership did not know was that the explosion was a calculated act of technological sabotage. The Siberian pipeline had not been blown up by an airstrike or artillery. It had been detonated by a malicious subroutine embedded deep within the software that operated their most critical economic infrastructure. This hidden digital trap silently broke the industrial backbone of the USSR, accelerating a series of economic shocks that would strain the communist empire to its breaking point. The United States did not need to launch a fleet of bombers or fire a single nuclear warhead to strike at the enemy. They simply inserted a few characters of malicious code and let the laws of mathematics, physics, and software logic do the rest. To see how a multi-billion-dollar mega-project was destroyed with code, we have to look at the state of the Soviet economy in the late 1970s. Because the Kremlin allocated as much as 20% of the nation's entire gross product to the military, the civilian economy was hollowed out. Citizens waited in freezing 5-hour lines for basic necessities like bread or soap. Most critically, the USSR was falling behind in the digital revolution. While American corporations were unleashing microprocessors and automated software, Soviet computer factories were decades behind, producing unreliable vacuum tube mainframes prone to overheating and catastrophic crashes. The state lacked the ultra-pure silicon fabrication facilities required to mass-produce reliable microchips, yet the Soviet military apparatus required advanced microchips to guide cruise missiles and operate complex industrial infrastructure. Unable to invent this technology natively, the Kremlin turned to the KGB. They established a colossal espionage empire, directed by a multi-thousand-page catalog known as the VPK Tasking Book. This was essentially a global shopping list for stolen Western technology, executed by an elite network of deep-cover intelligence officers known as Line X. Line X operatives infiltrated aerospace firms and established dummy front companies across Europe, with consistent success. By 1980, Soviet radar systems were direct clones of American designs. Their cruise missile navigation systems were built around stolen Silicon Valley circuit blueprints, and they even managed to steal the complete technical schematics for the Concorde supersonic airliner. The Soviet military-industrial complex was matching the United States step for step without spending a single ruble on domestic innovation. It was an empire built on an invisible supply line of stolen Western secrets. The Kremlin believed their covert empire was completely impenetrable until a KGB electronic engineer named Vladimir Vetrov made a fateful decision. Disillusioned by the systemic corruption of the Soviet regime, Vetrov made contact with French counterintelligence under the code name Farewell. Over a year, using miniature cameras, he photographed over 4,000 classified Soviet documents detailing the exact scientific gaps the KGB was trying to fill. In July 1981, French President François Mitterrand pulled Ronald Reagan aside during a private walk at the G7 summit in Ottawa. Mitterrand handed over the Farewell dossier, exposing the true identities of more than 200 Line X intelligence officers and the exact technologies the Soviets were targeting for theft. Initially, American counterintelligence wanted to immediately arrest every Line X officer and shut down the front companies, But National Security Council economist Dr. Gus Weiss proposed a different strategy. Let them steal the technology, but alter it before it leaves the country. Working with American manufacturers, the CIA deliberately altered the technologies the Soviets wanted most. They engineered microchips that functioned perfectly during bench testing, but dropped random data bits under the high heat of military aircraft radars. They provided doctored chemical formulas for high-strength titanium, causing turbine blades for Soviet fighter jets to develop microscopic molecular fractures and shatter after a few dozen hours of flight. The Soviet Union was paying its spy networks millions of dollars in hard currency to steal technology that had been engineered to destroy their industry. Operation Trojan Horse turned the Soviets' greatest strategic asset into their most fatal vulnerability. The focus of this operation centered on the energy infrastructure of Western Siberia. The Soviet economy was burning through its foreign exchange reserves, and the Kremlin's salvation lay in the Trans-Siberian gas pipeline. Stretching nearly 3,000 miles, it was designed to pump natural gas into Western Europe, generating $30 billion a year to bankroll the Red Army and insulate the regime from economic failure. This animated diagram shows the computerized central nervous system of a pipeline known as a SCADA system. Operating a high-pressure natural gas pipeline across thousands of miles of wilderness requires software to constantly monitor gas flow. The SCADA data loop takes readings from pressure sensors, feeds that data to a central processor, and automatically adjusts massive compressor turbines and emergency shutoff valves to prevent lethal pressure buildups. Without advanced computerized SCADA software, the pipeline could not operate safely. Soviet agents initially tried to purchase the systems legally from a Canadian manufacturer, but U.S. export authorities blocked the sale. Anticipating that the KGB would attempt to steal the proprietary software, a SCADA team worked with the Canadian company to insert a sophisticated logic bomb deep within the machine code. The software was designed to pass every rigorous laboratory test. When Soviet computer engineers installed the stolen code into the pipeline's control stations, the diagnostic screens showed perfect operating metrics. Every valve responded instantly, and initial test runs of low-pressure gas flowed smoothly. Soviet engineers believed they had successfully acquired the automation required to make the pipeline operational, but the code was programmed to monitor the pipeline's cumulative operating hours. After reaching a specific duration, the digital trap triggered. The logic bomb overrode safety parameters while sending false normal data to the operator monitors. Downstream, it commanded the computerized valves to slam shut, while simultaneously forcing the massive compressor turbines to spin up to supersonic speeds. Internal pressure exceeded 150 atmospheres, and the steel pipes ruptured with explosive violence. By exploiting the USSR's technological blindness, the United States managed to physically destroy the Soviet Union's most critical infrastructure entirely through algorithmic subversion. In the spring of 1983, Western governments delivered a final diplomatic strike. In a coordinated international effort, they expelled hundreds of Soviet diplomats and rolled up the entire Line X scientific espionage apparatus in a matter of weeks. Inside the Kremlin, the realization of what had occurred triggered an acute institutional breakdown. KGB leadership finally understood that the West possessed the complete archives of Directorate T, and that the Siberian pipeline explosion was a calculated American trap. Paranoia spread through the Soviet leadership as they realized that every piece of advanced hardware or software stolen from the West could contain a hidden digital assassin. They no longer knew which of their own blueprints could be trusted. To prevent further disasters, the Soviet government halted manufacturing assembly lines across the country. Thousands of scientists and engineers were pulled away from productive research to manually audit and verify millions of stolen components and lines of code. The physical fireball in Siberia was a significant industrial setback, but the resulting institutional panic crippled the Soviet system's ability to innovate. Years were wasted on audits, effectively freezing Soviet technological advancement at a moment of intense geopolitical competition. Vladimir Vetrov, whose discovery led to this breakdown, was eventually arrested. He was convicted of high treason and executed in the cellar of Lefortovo prison in February 1985. This technological paralysis arrived at a critical moment. When President Reagan announced the Strategic Defense Initiative, a high-tech missile shield, the Soviet leadership knew their compromised computer industry could never hope to match it, leaving their nuclear deterrent increasingly vulnerable. The loss of pipeline revenue, combined with a sharp drop in global oil prices and the ongoing costs of the war in Afghanistan, stripped the Soviet state of its last remaining financial lifelines. By 1991, the USSR had dissolved. The 1982 Siberian explosion demonstrated a new reality in strategic conflict. It proved that a superpower's infrastructure could be physically compromised from the other side of the globe, marking the first major application of what we now recognize as cyber warfare.